Everyone. Hi, and welcome to my channel, Math Made Easy with Terry 10 minutes. Okay. In the previous video, I introduced the concept of binomial exponential with positive whole numbers, and I solved some questions on it. Okay. But now I'm going to solve more examples, and one of the examples I have on the board is we should use binomial theorem to find the first three terms in the ascending order. Okay, so we have this. Remember, the keyword here is the first three terms. So we have 1 plus x raised to the power what? 32. Okay? So what do? So here, remember, it must be in the form of a plus b raised to the power n. So that means our a is equal to 1, and our b is equal to x, and our n is equal to 32, right? A is 1, b is x, and 32. Now, if you put it in the formula straight up like this, you will notice that it's going to be A1. Sorry, let me clean this so to be clear. So it's going to be, if you put it like this, so it's going to be 1 to the power of 32, x raised to the power what? 0. Okay? Now, what do? Then we will now go straight. So it's 132, x to the power 0. Then plus 1 to the power 31, x to the power 1, plus 1 to the power what? 30, x to the power what? 2. Remember, we were asking the first two terms in ascending order of x. So x to the power 0 is the first term, this is the second term, and this is the what? Third term. So we are done now. Then, but we have to put the coefficients. So it's going to be 32 combination 0, 32 combination 1, and 32 combination what? 2. Then what can we do now? We'll now put it in the formula. 32 combination 0 is, remember I told you anything raised to the power 0 is 1. Anything, okay, that is all. 32 combination 0 is 1 times 1 times 1, okay? Plus 32 combination 1 will give you 32 times 1 raised to the power 31 will give you 1 times x, plus 32 combination 2 should give you 496 times 1 times x squared. Then that will give you 1 plus 32x plus 496x squared. And that will give you that. Okay? That will be the answer for that. So because the question said the first three terms, so it's not necessary to solve all the questions, okay? So let's solve another one. Let's assume we're told to find maybe the first 4 terms, okay? Let's do something on the first 4 terms. Let's say I want to have something that has a fraction now. Let's say we have 1 plus 1 over 3y raised to the power 10. The first 4 terms. So we're having 1 plus 1 over 3y to the power 10. So the a is equal to 1. The b is equal to 1 over 3y. Then our n is equal to what? 10. So you put it in the formula as well. Okay, so it's going to be the first 4 term is going to be 1 raised to the power 10, okay? And 1 over 3y raised to the power, or you can put it to make it easy for you. 1 over 3y is the same thing as y over 3. Okay, if I put it like this, it's the same thing raised to the power 0. Okay, so if you say 1 over 3y, it's the same thing as y over 3. Okay, plus the next one is going to be 1 raised to the power 9. Y over 3 raised to the power what? 1, plus the next one is going to be 1 raised to the power 8, y over 3 raised to the power 2. Is that making sense? Then plus the next one we're going to have is 1 raised to the power 7, and y over 3 raised to the power what? 3. So we're having the 4 terms, 1, 2, 3, 4. Then we'll stop there, okay? Now you have to be careful and know if they say ascending power of y, that means we'll have to start. But if it's the other way around, then you have to swap the variables, okay? So, but in this case, we're not told it has to be in any particular order. So that means this is going to be 10 combination 0. We're going to give you 10 combination 1, and that'll give you 10 combination 2, and 10 combination 3. All right. So with that, now we can now solve it. So remember, I told you anything raised to the power of 0 will give you what? 1. So this is going to give you 1. So that will give you 10 combination 1 is 1 multiplied by 1 times 1 plus 10 combination 1. 10 combination 1 will give you 10 times 1, then times y over 3 plus. So when you solve 10 combination 2, you press in your calculator, it should give you 45 times 1 times y squared over what? 9. Okay, plus. Then 10 combination 3 should give you 120 times 1 times. This should give you y3 over 9 times 3 is 27. Then when you simplify this, it's going to give you 1 plus 10y over 3, okay, plus. This should give you 49 divided by that, give you 5y squared plus. Then 120 over 47 is the same thing as saying 40 over what? 9y3. And this is the answer for this. All right, and that'll be that. What we can do, I can pick one more example. So what I will advise you to do is I want you to pause the video, all right? So just pause the video. When I write the questions, try and solve it. And then you can play it again and see if you get the same answer. So let's say we're told to find the first 3 times, okay? So we want to do the first 3 times of this. First 3 times of 3 minus 5z. Okay, raised to power what? 14. So we're looking for the first 3 terms. Now, if the question wants you to find the first 3 terms in the ascending power of z, okay? So let's say I want to make it a little bit more tricky now, and I want to make it like we're finding the first 3 terms in the ascending power of z. So in the ascending power of z, okay? So it's going to be the same thing. So it's going to be, we have 3 minus 5z is about 14. So A is equal to the 3, our B is minus 5z, and our C, N, is going to be 14. So it's going to be 3 raised to the power of 14. Now, in this case, it's going to be minus 5. Is that making sense? Minus 5z raised to the power what? 0. Okay? Plus. So that means because it's going to be the ascending power of z, z must be the one to take the 0. But if, for instance, it's in the descending power, does that make sense? If this question was, for instance, in descending, let's assume it was descending. So you have to swap it. So it's going to be 3 raised to the power 0 and minus 5z raised to the power 14. Can you see? But because it's in ascending, you have to start with z raised to the power 0. But if it was descending, it has to be z has to have the highest number, then you keep on bringing it down. Is that okay? So please don't forget that. It's a very important thing to take note and jot in your notebook. Then we now have 3. Sorry, let me change the color. So that's removing this. Then we have 3 raised to the power 13 and minus 5z raised to the power 1. So you notice as well, because of the minus, I also put the minus as part of the b. So it's not going to be just 5z. The minus has to be part of it. Plus 3 raised to the power what? 12 and minus 5z raised to the power 2. Okay. Then when you're done with that, you then have to put the combination. So it's going to be 14 combination 0, 14 combination 1, and 14 combination what? 2. Then, remember I told you anything raised to the power of 0 is what? 1. So all this is going to be 1. Then put it to your calculator. 14 combination 0, press your calculator, should give you 1. Then 3 raised to the power 14 will now give you, so just to make it simple, I'm not going to just, I'll just leave it as 3 raised to the power 14, okay? So you can press your calculator to give you the answer for that. Then 14 combination 1, when you press your calculator for that, should give you 14 times 3 raised to the power what? 13 times minus 5 what? Z plus 14 combination 2 should give me 91 times 3 raised to the power 12 times, that'll give me 25Z squared. Okay, and when we have that, you can now simplify. So give me 3 raised to the power 14 minus, or you can put plus, then inside will be minus. When you open the bracket for that, it should give you 770Z, I beg your pardon, 3 raised to the power 13, okay? Then when you do that as well, it should give you 202.75 Z squared and 3 raised to the power 12. So you can decide to open the brackets if you want to simplify, but I can just leave it like this. So it will now be minus 70Z, 3 raised to the power 13, plus 202.57 Z squared, 3 raised to the power 12. And that should be the answer for that. All right, so I think that is that. The next, what I'm going to work on next, I'm going to go straight to negative powers. So I'm going to do binomial expansion with negative powers and fractional powers in the next video. So remember, just a quick recap, when you are using Pascal's triangle, it has to be only positive whole numbers. But for binomial expansion, you can use it for both positive and negative or fractional. So I've talked about the positive now for binomial. So the next video, I'm going to talk about binomial with negative or fractional power, okay? If you have any question, feel free to drop it in the comment section, and I'm going to talk about it. Or if you want me to talk about a particular video, you can put it in the comment section. And please subscribe, so when I upload the video, you will know when I have uploaded new videos. All right, thank you very much. So see you in the next video.